Have you ever wondered, if time doesn't truly exist, then what is holding the universe together right now? They say, the Big Bang created everything, but what created the Big Bang? What if I told you you may have already lived this exact life thousands of times before? Every breath, every choice, every mistake, echoing in parallel. In the next few minutes, you will never see time and space the same way again. There is a paradox that even Einstein lost sleep over. And tonight, we are unlocking the secret humanity has missed for thousands of years. Please like and subscribe, because this journey will change how you see our place in the universe. Prepare yourselves. We begin. In 1828, an amateur cartographer named Edward Quinn tried to capture the story of human discovery in a book he called the Historical Atlas. His maps weren't ordinary maps. They didn't just show geography. They showed ignorance itself, dark clouds hanging over continents, veiling the unknown, retreating only as history advanced. With each page, the fog of mystery rolled back. First came the rivers of Mesopotamia, then Egypt, then Rome. Page by page, the world was revealed, until by the 19th century the clouds had lifted entirely. Nothing, it seemed, remained hidden. But here's the paradox. Quinn thought he was showing the world. In truth, he was showing the human mind. For the Atlas wasn't really about oceans and continents. It was about perception, about the endless struggle between darkness and light, ignorance and knowledge. And this metaphor did not stop at the borders of Earth. Just as the continents were once veiled, so too has the cosmos been hidden behind layers of mystery. Clouds that were not drawn in ink, but clouds of physics, of distance, of imagination. For thousands of years, we looked up at the stars and believed we understood them. They were lights in a crystal dome, lanterns carried by gods, eternal fires. Slowly, painfully, we learned otherwise. With telescopes, we pulled back the veil. Stars became suns, nebulae became galaxies, black holes, quasars, pulsars, all hidden once behind the fog. We reached backward in time, to the afterglow of creation itself, and still, the clouds continue to roll away. But each time a mystery lifts, a greater one takes its place. Like Quinn's Atlas, we think we are approaching the end of discovery, and each time, we are wrong. In the 19th century, astronomer Simon Newcomb declared that astronomy was nearly complete. Within a decade, Einstein's equations shattered that illusion. Today, we are more advanced than Quinn, more advanced than Newcomb, yet the same hubris haunts us, the belief that we have nearly arrived. But the universe is not so simple. Its greatest secrets are not buried in distance, but in paradox. Not just in how far our telescopes can see, but in how deep our minds are willing to dive. Because the next cloud of mystery does not lie at the edge of space, it lies at the edge of reality itself. And here we arrive at a breathtaking idea, that our universe, this cosmos of stars and galaxies, is not alone. That beyond the horizon of what we can see, beyond the thin veil of our perception, there may exist countless other universes, realms with their own galaxies, their own physics, their own histories. Some may be lifeless deserts, some may teem with alien wonders, and some, this is the part that defies comprehension, may look exactly like ours. What Quinn's clouds were to geography, these paradoxes are to existence itself. They remind us that what we call everything may be just a page in a much larger atlas, and that the fog of unknowing is not retreating, it is multiplying. Every answer we uncover births 1,000 new questions. Welcome then to the multiverse. Not a single theory, but a chorus of them. Not a clean map, but a storm of speculation, woven from mathematics, quantum physics, and philosophy. A warped Russian doll of infinities, where each universe contains within it the seeds of others. In the chapters ahead, we will wander through this cosmic atlas, universes born beyond our cosmic horizon, universes sprouting like bubbles in an eternal foam, universes branching with every quantum decision, universes woven purely of mathematics, where existence itself is an equation, Each theory promises answers. Each theory multiplies the mystery. And together they form a picture at once, terrifying and beautiful. That reality may be infinite in scope, infinite in possibility, infinite in meaning. But before we dive into equations and paradoxes, we must linger here, at the threshold. For to truly grasp the multiverse, we must accept a simple but unsettling truth, that what we see is not all their island. Our observable universe, the galaxies, the stars, the very atoms of your body is nothing more than a small patch, a window carved in fog. Beyond it, that is the journey we are about to take. And so, as Quinn once peeled away the clouds to reveal Earth, let us peel away the clouds of physics to reveal reality itself. Each layer we strip back will show us not certainty, but possibility. Not an end, but an opening. For this is the paradox of knowledge. The closer we get to truth, the stranger it becomes. And somewhere out there, perhaps not far from here, the first whispers of another universe are waiting. There are moments in history when human arrogance meets its match, when certainty collides with discovery, and the universe pulls the rug out from under us. One such moment unfolded in April of 1920, inside the Smithsonian Museum of Natural History in Washington, D.C. Two men took the stage before an audience of astronomers, journalists, and curious citizens. Their question was deceptively simple: how big is the universe? On one side stood Harlow Shapley, a brilliant mind, known for mapping the distribution of stars across the Milky Way. Shapley carried himself with the authority of a man who believed he already had the answer. The Milky Way, he declared, was the universe. Vast, magnificent, but self-contained. Everything we could ever know was right here, spinning within our galactic island. Across from him stood Heber Curtis, a quieter figure, a man who had peered through telescopes at strange, ghostly spirals in the night sky. To him, these were not mere curiosities floating inside the Milky Way. No, Curtis suspected they were galaxies in their own right. Island universes, he called them. Entire cosmic continents, millions of light years away, each home to billions of suns. It was a clash not just of theories, but of worldviews. Shapley's universe was comforting, grand, but bounded, knowable. Curtis's vision was terrifying, an unending sea of galaxies stretching into darkness, where our Milky Way was just one among countless others. The debate raged for hours. Each man argued his case, pulling from the limited data of the time. Shapley leaned on the size of the Milky Way, which he believed was so immense it left no room for others. Curtis pointed to the faint novae spotted in Andromeda, hinting that this spiral nebula was much farther than Shapley dared imagine. When the lights dimmed and the audience left, there was no winner. The universe remained unsettled, caught between two possibilities: a compact cosmos that ended with our galaxy, or an abyss of unfathomable scale. But the truth does not wait for consensus. Even as Shapley and Curtis debated, on the far side of the country, a young astronomer named Edwin Hubble was preparing to rewrite reality itself. Hubble was stationed at Mount Wilson Observatory in California, home to the newly installed Hooker telescope, the largest in the world at the time. Its 100-inch mirror, a mechanical marvel that could gather the faintest whispers of starlight. Hubble was ambitious, restless, driven by a single question: just how far does the universe go? He turned his attention to the Andromeda Nebula, that hazy smear of light Curtis had championed as another galaxy. Through his telescope, Hubble searched not for novae, but for a specific kind of star, a Cepheid variable. These stars pulse with a rhythmic brightness, and Henrietta Swan Leavitt, one of the most overlooked geniuses in astronomy, had discovered their secret. The longer the pulse, the brighter the star truly was. And from that brightness, you could calculate its distance. Hubble combed through the Andromeda Nebula with patience and precision, hunting for these cosmic lighthouses, and then he found them, stars beating slowly, far too luminous to be near. They were not part of the Milky Way. They were hundreds of thousands of light years beyond it. The conclusion was undeniable. Andromeda was not a cloud inside our galaxy. It was a galaxy of its own, a sprawling island of suns separated from us by unimaginable gulfs of space. In 1924, Hubble sent a letter to Shapley, a short, devastating note that overturned centuries of certainty. Andromeda was another galaxy, and therefore the universe was far larger than anyone had dared believe. Shapley's reply is one of the most poignant sentences in the history of science. Here is the letter that destroyed my universe. Imagine it, to believe you know the boundaries of everything, only to be told that everything is just the beginning. To discover that the map you've spent your life drawing is not a map at all, but a single grain of sand on an endless shore. This was not merely a scientific revelation, it was a spiritual one. Humanity had been demoted again. First, Copernicus had dethroned Earth from the center of creation. Now, Hubble had dethroned the Milky Way itself. The fog rolled back, and in its place, a horizon without end, galaxies upon galaxies, each containing billions of stars. The universe had become not just bigger, but boundless. The emotional weight of this discovery cannot be overstated. The audience in 1920 had come to hear two astronomers argue over scale. What they got instead, just a few years later, was the death of every small universe humanity had ever clung to. The 20th century became a century of horizons. With larger telescopes and better detectors, we measured not just millions of light years, but billions. Galaxies became clusters, clusters became superclusters, until the universe revealed itself as a vast cosmic web, strands of light woven across a darkness so immense the human mind can scarcely contain it. But with this new scale came a new kind of terror, because the larger the universe grew, the smaller we became. The Milky Way, once thought to be the whole, was reduced to a single speck. Earth became a speck within a speck, and you, your thoughts, your loves, your fears became an almost invisible flicker in the immensity. And yet, paradoxically, this demotion was also liberation. For if there are countless galaxies, then who is to say there are not countless possibilities, countless ways reality might unfold? The death of Shapley's universe was also the birth of the multiverse imagination. The great debate of 1920 was not really about galaxies. It was about human perception colliding with truth. It was about the fragility of certainty, the arrogance of thinking we had reached the end of discovery. Curtis, in the end, was right, but the universe, in its strange generosity, gave Shapley a gift too. For though his theory collapsed, it prepared us all for the shock to come, that the universe we inhabit is not only larger than we thought, it may not even be alone. Because once the fog cleared to reveal galaxies, we had to ask, what lies beyond galaxies? Once the horizon widened, we had to ask, is there a horizon at all? Hubble's letter destroyed a universe, but it also built a doorway, and through that doorway, we are about to step into realms where our cosmos is just one page in an infinite atlas. It is hard to imagine the weight of a single envelope, fragile paper, ink scrawled by hand, yet inside it, an idea powerful enough to shatter a universe. In 1924, Edwin Hubble sealed such a letter. It was addressed to Harlow Shapley, the great astronomer who only 4 years earlier had stood before the world to defend his vision of a compact cosmos. Inside, Hubble quietly destroyed that vision. He had been hunting Cepheid variable stars in the Andromeda Nebula, and he had found them. Their rhythmic pulses told him their true luminosity, and from that, their staggering distance. These stars were far too remote to belong to the Milky Way. They were members of an entirely separate galaxy. And if Andromeda was another galaxy, then the Milky Way was not the universe at all. It was just one island among billions. When Shapley opened that letter, he is said to have murmured a line that captures the heartbreak of intellectual defeat. Here is the letter that destroyed my universe. Pause there for a moment. Imagine receiving news that everything you believed, everything you taught, everything you built your life upon was wrong. That your cosmos, the all-encompassing frame of existence, was only a small corner of a larger reality. This was more than astronomy. This was existential collapse, because for centuries, humans had fought to preserve a central place for themselves. We resisted Copernicus when he dethroned Earth from the center of creation. We resisted Darwin when he dethroned humanity from the pinnacle of life. And now, Shapley felt the final blow. The Milky Way itself, our cosmic home, dethroned from being the totality of existence. The universe was not a cozy neighborhood. It was a vast, unending wilderness, and we were adrift inside it. Hubble's discovery spread like wildfire. Newspapers declared humanity's demotion with awe and dread. Other universes revealed, one headline cried. Of course, they meant galaxies, but the word universes carried its own poetic truth. For every galaxy was an entire realm, a cosmos unto itself, with billions of suns and countless possible worlds. Suddenly, our imagination strained against the infinite. If Andromeda alone was another universe, how many more waited in the darkness? Telescopes soon revealed the answer. Millions, then billions. The night sky was no longer a scattering of stars. It was an ocean of galaxies. Astronomy had not just redrawn the map. It had torn the map to pieces and replaced it with a horizon that receded faster than we could chase it. Think of what this means in human terms. If you stood on a beach, staring at the ocean, you might feel small, but you also see an end, the horizon, the curve of Earth. But with Hubble's discovery, the ocean had no shore. It extended forever, and we were a grain of sand at the bottom of an endless abyss. It was terrifying, but it was also liberating, because in that abyss, anything was possible. The Andromeda Galaxy became a symbol of this paradox. In 1924, it transformed from a fuzzy patch of light into an island of stars, as real and as vibrant as our own Milky Way. And with that transformation came a haunting realization. If there are other galaxies, then perhaps there are other Earths, other versions of life, other stories being written under different suns. But Hubble's revelation carried a deeper lesson, one that still echoes today. Our greatest discoveries are born not from certainty, but from collapse. Shapley's universe had to die for a larger truth to be born. Just as our personal certainties must sometimes shatter before we glimpse the bigger picture of our own lives. The universe is ruthless in this way. It does not coddle us. It does not care about our comfort. It expands endlessly, mercilessly, whether we are ready or not. And in that expansion, it demands that we expand too, not our galaxies, but our minds. From this moment forward, cosmology was transformed. The 20th century became a century of scale. Telescopes grew larger, and with them, our conception of reality. The Milky Way shrank to a single dot among clusters, superclusters, filaments of galaxies stretching like luminous threads across space. The cosmos was not static either. Hubble himself soon discovered that these galaxies were racing away from us, their light stretched by expansion. The universe was not fixed. It was growing, alive, dynamic. Every step forward widened the abyss. But every step forward also gave us a deeper sense of belonging, not because we were central, but because we were part of something vast beyond comprehension. And here lies the real significance of Hubble's letter. It was the first time humanity collectively felt the vertigo of infinity. Until then, the universe was large, yes, but bounded. The Milky Way contained everything. It was an idea that gave us closure. But after 1924, closure was impossible. The fog had lifted, and in its place was an abyss. Curtis had been vindicated. Shapley had been undone. But in truth, both men had been too small in their imagination. Neither could have dreamed of the cosmic web we now know, stretching across tens of billions of light years, laced with dark matter and dark energy, holding secrets we have not yet begun to fathom. So what do we learn from this story? That every end of discovery is an illusion, that the clouds of ignorance Quinn once drew never fully disperse, they only shift, revealing deeper mysteries, and that sometimes a single observation, a single letter, is enough to destroy an entire universe and replace it with one infinitely grander. Hubble's discovery was a beginning disguised as an ending. It was the destruction of Shapley's cosmos, but also the birth of ours. And even as it expanded our vision, it whispered a question that lingers to this day. If our galaxy is not alone, what else is not alone? Because if the Milky Way was never the universe, perhaps the universe itself is not all their island. Perhaps reality too is just another nebula, waiting to be reclassified. And so the story moves forward, from galaxies to the very edge of sight, from Hubble's telescope to the background glow of creation itself. For beyond Andromeda, beyond even the most distant galaxy, lies another horizon one that may not only hide more stars, but more universes. The letter that destroyed Shapley's universe may, in the end, have destroyed ours too, because once you accept that your universe is not the whole, you can never go back. Every map ends somewhere. For Quinn, it was the edge of parchment, where clouds swallowed the unknown. For Hubble, it was the dim limits of his telescope, where galaxies dissolved into haze. But in the 20th century, astronomers pressed further still, pushing against the very boundary of visibility. What they found was both a wall and a window, the edge of sight, the moment where the universe itself first became visible. In 1964, two radio engineers, Arno Penzias and Robert Wilson, were testing a large horn-shaped antenna in New Jersey. They were not searching for the origin of the cosmos, they were troubleshooting static, a hiss of radio noise that refused to vanish, no matter how carefully they cleaned the equipment, no matter how they adjusted the dials. They even removed pigeon droppings from the antenna, convinced that cosmic history had nothing to do with stubborn birds. But the hiss persisted, and then came the revelation. What they were hearing was not noise at all, but the oldest light in the universe. A faint glow, stretched thin across the sky, a relic from the birth of time itself. The cosmic microwave background light that had been traveling for 13.7 billion years, carrying the story of creation to our ears. It was as if the universe had whispered, "Here is my beginning. Here is the first page of the atlas." This discovery drew a line across our maps of reality. Beyond the cosmic microwave background, no telescope could see. It was the fog of birth, the moment when the universe cooled enough for light to escape matter, when particles stopped scattering photons like a storm cloud and allowed the cosmos to become transparent. Before that moment, light was trapped, bouncing endlessly in a dense plasma. After that moment, it was free, stretching ever since into the microwaves we can now detect. The boundary was set, not by geography, not by technology, but by time itself. To look further back than this would be to look into darkness before light. And so, the cosmic microwave background became both a horizon and a clue, both an end to sight and a beginning of imagination. What lies beyond this wall? The equations whispered an answer: more universe, more galaxies, more stars, more possibilities. The observable cosmos, the 4-6 billion light-year bubble we inhabit, is not all their island. It is just the part from which light has had time to reach us since the Big Bang. Beyond it stretches what? Here we meet the first infinity. If space has no curvature, if it is flat on the grandest scales, then it must go on forever. No edges, no borders, just endless expanse in all directions. This is a paradox that shakes the mind. How can something born a finite time ago, 13.8 billion years, be infinite in extent? Shouldn't a beginning imply boundaries? But the math says otherwise. From the instant of birth, the universe was not a point expanding into emptiness, but space itself expanding everywhere, all at once. Even when it was only a fraction of a second old, it may already have been infinite. An infinite cosmos born in a finite moment. A paradox we must swallow, or else abandon the equations that have otherwise described reality with uncanny precision. If infinity is true, then our bubble of observability is just that, a bubble. Around us lies not emptiness, but an unending ocean of galaxies we will never see. Each distant world with its own stars, its own elements, its own stories written in light we will never touch. For every star that shines within our horizon, there may be countless more beyond, flickering unseen in the dark. The edge of sight, then, is not the edge of being. It is the edge of our being, the boundary of what we, fragile creatures on a pale dot, can ever know. Beyond it, the cosmos continues, indifferent to whether we can follow. And yet, as breathtaking as this infinity is, it comes with a cruel twist. For just as our horizon once expanded, revealing galaxies and clusters we had never dreamed of, it is now doomed to contract. At the close of the 20th century, astronomers discovered that the universe is not just expanding, but accelerating, driven by a mysterious force we call dark energy. This acceleration changes everything. Galaxies that were once visible are now being pushed beyond our horizon faster than their light can reach us. With each passing moment, the universe is slipping away. Look up at the night sky. The faint galaxies you see are already ghosts, their light a farewell message from worlds we will never touch again. In 100 billion years, only the Milky Way and its closest companions will remain. The rest, the 2 trillion galaxies we know exist, will vanish into darkness, unreachable forever. The atlas of the universe is not static. Its clouds do not retreat endlessly. They also return. The fog of unknowing is thickening again, not from ignorance, but from inevitability. And so, we live in a privileged time, a cosmic dawn, when the universe is still visible, when the light of distant galaxies still graces our telescopes. Future civilizations may never know what we know. They will look up and see only emptiness, only a sterile darkness beyond their stars. The evidence of a vast cosmos will be erased, leaving them with a false map, just as Shapley once believed. The Milky Way was all their island. We, however, stand on a narrow ledge of knowledge, peering both backward to the afterglow of creation and outward to the edge of infinity. We are the first generation to map the universe in its fullness, and perhaps the last to ever see it this way. What, then, does it mean to be human at the edge of sight? It means to live inside a paradox, to know that reality is infinite, yet to be confined within a horizon, to see further than any creature before us, yet to know we are blind to almost everything, to stand in a moment where the universe reveals its immensity, even as it slips away. And perhaps this is the deeper truth. The edge of sight is not a barrier meant to frustrate us. It is an invitation, a reminder that knowledge is always partial, that mystery is eternal, that the fog of Quinn's atlas was not erased, it was only transformed. For beyond the horizon lies not just more universe, but the possibility of other universes. If infinity is true, then somewhere out there, beyond all reach, there may be another Earth, another you, watching another night sky, asking the same questions. The cosmic microwave background is not the end of discovery, it is the beginning of wonder. And from here, the journey shifts. From galaxies and horizons, we now step into speculation itself, into the first true visions of the multiverse, where infinity is not just a number, but a reality, where our universe is only one page among many. What if I told you that the universe you see tonight, the galaxies glowing faintly at the edge of sight, will not always be there? That the grandest truths we have uncovered are temporary, slipping away even as we celebrate them? This is not a poetic metaphor, it is physics. At the end of the 20th century, astronomers made a discovery so shocking it reversed our vision of the future. For decades, scientists believed the universe's expansion, set into motion by the Big Bang, was slowing down. Gravity, they thought, would fight the outward push. Perhaps the cosmos would expand forever, cooling into stillness. Perhaps it would collapse back upon itself in a fiery, big crunch. But in 1998, 2 teams studying distant supernovae, the dying explosions of stars, found something strange. These cosmic mile markers, flickering billions of light years away, were dimmer than expected. The meaning was clear. They were farther away than they should have been. The universe was not slowing down, it was accelerating. The culprit? A force we had never seen, never touched, never measured, yet one that dominates reality. A repulsive pressure embedded in the fabric of space itself. We gave it a name as vague as our understanding: dark energy. Dark energy now makes up nearly 70% of everything. It is not matter, it is not light, it is not even dark matter, the invisible glue that holds galaxies together. It is something else entirely, a ghostly expansion woven into space-time, and its consequence is merciless. Galaxies are being pushed away from us faster and faster, carried beyond the reach of even light. Imagine it like this. The universe is an ocean. and we are sailors in a small boat. At first, the waters seemed calm, the horizon fixed. Then the tide began to rise, slowly at first, then surging. Islands we once glimpsed have been swallowed. The ocean stretches endlessly, but we are stranded on a shrinking raft of stars. Today, we estimate there are about 2 trillion galaxies within our observable universe. But here is the cruel twist. More than 99% of them are already lost to us. Even if we built ships that skimmed close to the speed of light, we would never arrive. Their light may still reach us for now, but their presence is an illusion they are receding too quickly for us to ever touch. They are ghosts fading before our eyes, and the future grows darker still. In 100 billion years, only our local group of galaxies, the Milky Way, and a handful of companions will remain visible. Beyond them, nothing. The sky, once a tapestry of stars and galaxies, will be stripped bare, an endless black. Think of what that means. Future civilizations, if they exist, will live in a prison of illusion. They will look at the heavens and see only their own galaxy. They will believe it is the whole of existence, just as Shapley once believed. The evidence of the Big Bang, the proof of an expanding cosmos, will be gone. The cosmic microwave background itself will fade into invisibility. To them, the universe will appear static, eternal, and solitary. Our age, then, is a cosmic privilege. We are alive in a fleeting moment when the universe still reveals its immensity, when we can still map the galaxies, still measure the afterglow of creation, still sense the vastness beyond. We are astronomers in a golden hour, standing between dawn and dusk, able to see what no future eyes will ever see again. And yet this privilege is a burden too, for to know the truth is to feel its weight. To understand that most of the cosmos is already lost to us forever is to feel a loneliness deeper than any personal solitude. The night sky becomes not just a wonder, but a farewell. Every distant galaxy is a letter from the past, arriving late, from a sender we will never meet. This is the paradox of discovery. The more we see, the more we lose. The brighter our understanding, the darker our horizon becomes. And in this paradox, we must find meaning. Some see despair in this vision. What good is a universe we can never reach? Why map a cosmos that is vanishing? But perhaps this is the wrong question. Perhaps the value of knowledge is not in possession, but in awareness. The galaxies do not need us to reach them. Their beauty lies in their existence, in the testimony that reality is larger than ourselves. In a way, dark energy is a cosmic teacher. It strips away our illusions of control, reminding us that we are not masters of the universe, but witnesses to it. And what a gift, that witnessing island, to live in an age when the cosmic atlas is open, when the fog has retreated just enough for us to glimpse the infinite, is to be given a rare and fleeting privilege. But the mystery of dark energy runs deeper still, for its discovery does not just change our future, it changes our very understanding of reality. Why does space itself push outward? Why now? Why with this exact strength? Too weak, and the universe would have collapsed long ago. Too strong, and stars would never have formed. Once again, we find ourselves staring at fine-tuning, at the strange coincidence that the laws of physics seem balanced on a knife's edge to allow our existence. And once again, we are driven toward a radical possibility. Maybe this is not the only universe. Maybe ours is simply one of countless realities, each with different laws, most lifeless, some dead from birth. And by chance or by something deeper, we find ourselves in one of the rare few where life can exist. Dark energy, then, is not just a force of expansion. It is a doorway, a hint that our cosmos is not unique, that the vanishing universe may be pointing us toward the multiverse. Stand under the stars tonight. Look at the Milky Way, stretching across the sky. Know this, it is not just a view of space, it is a view of time. Every star, every galaxy, is a relic of light sent long ago, and many of those lights are final farewells, the last photons we will ever receive before their galaxies vanish forever. The cosmos is slipping through our fingers, but perhaps this is not tragedy. Perhaps it is invitation, an invitation to seek meaning, not in conquest, but in contemplation. To understand that our place is not at the center of everything, but as witnesses to an infinite unfolding. The vanishing cosmos does not diminish us, it deepens us. It forces us to see that the value of existence is not in its permanence, but in its fleeting wonder. And so, as galaxies drift beyond our reach, let us not mourn, let us marvel. For the universe is not closing, it is opening into questions so vast they demand new maps, new visions, new theories of reality itself. This is where the multiverse begins to emerge, not as speculation, but as necessity. For if our universe is vanishing, then perhaps there are others where the story is written differently. Other realities where expansion follows other rules, where galaxies remain forever, where time itself unfolds in ways we cannot imagine. The vanishing cosmos is not the end, it is the threshold. Infinity is a word we toss around lightly. We say the sky is infinite, or possibilities are infinite, without truly feeling the abyss it represents. But in cosmology, infinity is not poetry. It is a mathematical conclusion. If space is flat, as our best observations suggest, then it does not curve back on itself. It does not loop into closure. It stretches outward without end. And if that is true, then our universe, as vast as it feels, is just a small patch in an endless expanse. This is what physicist Max Tegmark calls the Level 1 multiverse, an infinite cosmos where our observable universe is only one bubble among countless others, each centered on its own horizon. Imagine you are standing on a plane that stretches forever in every direction. Around you is a circle of sight, the farthest you can see before haze swallows the horizon. That circle is your observable universe. But beyond it, the plane continues. Other circles of sight exist, centered on other observers, and on that infinite plane, there are an infinite number of circles, each one a universe, each one just as real as ours. At first glance, these universes beyond our horizon seem ordinary, just more galaxies, more stars, more matter arranged in familiar patterns. But here is where infinity plays its cruel trick. In an infinite cosmos, every arrangement of atoms must eventually occur, not just once, but an infinite number of times. Somewhere, unimaginably far away, there is a galaxy identical to the Milky Way. Within it, a star identical to the Sunday, and orbiting that star, a planet identical to Earth. On that Earth, there are oceans, forests, cities, and people identical to you. Another you is living another life right now. They are watching this same video, hearing these same words, wondering the same thoughts. Their life has unfolded exactly like yours, down to the smallest detail. It sounds impossible. It feels absurd. But infinity makes the absurd inevitable. In a truly infinite space, every possibility is realized not once, but endlessly. The idea of cosmic doppelgängers forces us into uncomfortable questions. If another you exists, exactly identical, are they you, or are they something else entirely? Where does identity end and repetition begin? If your choices are mirrored elsewhere, does free will survive? Or are you simply a pattern, repeating endlessly across infinity? Tegmark once calculated the likely distance to your nearest cosmic twin, about 10 to the power of 118 meters away. That number is so large it crushes the imagination. Our observable universe, by comparison, is only about 10 to the power of 27 meters across. Your twin is not just over the next hill or across the galaxy. They are unimaginably far, sealed away forever beyond our reach. And yet, distance does not diminish existence. Just because we cannot touch them does not mean they are not real. They are written into the logic of infinity itself. But it does not stop with one twin. In an infinite cosmos, there are not just 2 of you or 10 of you. There are an infinite number of you. Some live lives indistinguishable from yours. Others diverge at a single choice, a coin flip, a missed train, a conversation that went differently. And some live lives so alien to your own that you would not recognize yourself within them. Every possibility exists somewhere, etched into the endless fabric of space. Every triumph, every tragedy, every version of your story. Somewhere, you are a king. Somewhere, you never existed. Somewhere, you are still reading these words 1,000 times over. This is the unsettling beauty of level 1, the realization that our universe is not unique, but one tile in an infinite mosaic. Of course, we are trapped within our bubble. We will never travel those distances, never bridge the causal gap that separates us from our twins. The speed of light has locked us into solitude, but solitude does not erase reality. The galaxies beyond our horizon are as real as those we can see, their light simply too distant to reach us. The level 1 multiverse is not science fiction. It is the most conservative conclusion drawn from cosmology. If space is infinite and matter is distributed more or less evenly, then infinite repetition is unavoidable. The strange thing is not that copies exist. The strange thing would be if they did not. But what does it mean for us? Does the existence of another you diminish your uniqueness, or does it amplify it? After all, no copy, no matter how perfect, can live this life, in this moment, with this consciousness. Your awareness is still singular, even if your story is not. Perhaps the lesson is humility, that the universe does not revolve around us, that our lives are not singular jewels in a cosmic crown, but threads in an infinite tapestry. But perhaps it is also a reminder of meaning, for if the universe is infinite, then every possible beauty, every possible love, every possible act of courage exists somewhere, repeated endlessly. And that means the best of what we are is never lost. The level 1 multiverse does not answer the deepest mysteries. It does not explain why the universe exists, or why its laws are as they are. It does not reveal the engine behind creation. But it is the first step, the first widening of perspective. It teaches us that our observable bubble is not the whole, any more than Shapley's Milky Way was the whole. It is the first whisper that reality may be layered, nested, repeating, beyond anything we can directly perceive. And just as Hubble's letter destroyed Shapley's universe, so too does infinity destroy ours. Because once you accept the logic of the level 1 multiverse, you can never see yourself the same way again. You are not alone, you are legion. Stand under the night sky and look at the stars. Behind them lie galaxies. Behind those galaxies lie clusters. Beyond those clusters lie an ocean without shore. And somewhere in that ocean, another you is looking at another night sky, asking the same question. Infinity is not kind, it is not comforting, but it is real. And in that reality, we glimpse both our smallness and our vastness. We are copies, yes, but we are also originals. Each moment you live is unique, even if it repeats elsewhere. Each choice matters, even if it echoes across infinity. For meaning is not erased by repetition, it is written into it. This is only the first layer of the multiverse. Beyond it lie deeper, stranger realms, universes with different laws of physics, different dimensions, different births and deaths. But the level 1 multiverse is enough to shake our foundations. It asks us to stare into infinity, and in doing so, to confront ourselves, because the question is no longer, are we alone in the universe? The question is, are we even alone in ourselves? If level 1 shook us with infinity, countless copies of ourselves scattered across endless space, then level 2 takes a deeper leap. Here, the question is not just where we exist, but how. What if other universes are not simply more of the same, but fundamentally different in their laws, their constants, their very architecture of reality? To reach this possibility, we must journey back to the first heartbeat of time. The Big Bang was not a quiet dawn. It was an explosion of unimaginable violence, a moment when space itself was born and hurled outward. But the Big Bang alone does not explain everything. Why is the universe so smooth, so uniform, so delicately balanced? In the 1980 seconds, physicist Alan Guth proposed a radical solution: inflation. Inflation was not just expansion, it was a runaway acceleration in the universe's first fraction of a second. In less than a trillionth of a trillionth of a trillionth of a second, space grew from subatomic size to cosmic immensity. This exponential swelling ironed out wrinkles, stretched space flat, and seeded the patterns that would one day grow into galaxies. It worked. Inflation explained mysteries that had haunted cosmology, but as physicists dug deeper, a troubling detail emerged. Inflation did not end cleanly. Think of boiling water. Bubbles form and burst in chaotic rhythm. Inflation, it turns out, may behave the same way. In some regions, it stopped, cooling into familiar space and time. In others, it continued, expanding faster and faster. And here lies the revelation. Inflation may never end. While it ceases locally, birthing universes like ours, it rages on elsewhere, spawning more and more universes in an eternal cosmic froth. This is eternal inflation, a process without beginning or end, bubbling universes into being forever. Each bubble is a universe. Each one drifts apart, separated by ever-expanding space, never to touch, never to communicate. Our observable universe is just one bubble in this endless cosmic foam, and here is where the strangeness deepens. Each bubble is not necessarily the same. When inflation ends in one region, it crystallizes with particular physical properties, constants, forces, even the number of dimensions. Another bubble may crystallize differently. One might have weaker gravity, preventing stars from ever forming. Another might have stronger nuclear forces, burning stars out in seconds. Still, another might have more or fewer dimensions of space. Most bubbles are dead, sterile deserts without complexity, but a few rare, improbable land in the narrow range of parameters that allow atoms to form, stars to ignite, planets to orbit, and life to bloom. Our bubble is one of them. This is where eternal inflation intersects with a haunting question. Why does our universe seem fine-tuned for life? Consider the delicate balances. If gravity were slightly stronger, stars would collapse too quickly. If nuclear forces were weaker, carbon could not form. If dark energy were much larger, galaxies would never coalesce. The odds appear astronomically unlikely, as if the universe were rigged in our favor. Some see divine design in this, others see a statistical inevitability. In an infinite froth of universes, each with random laws, some will inevitably stumble upon the right combination. And of course, we find ourselves in one of those rare universes because only here could we exist to ask the question. This is known as the Anthropic principle. The universe appears tuned for life because life can only arise where the tuning is right. We do not live in a special bubble, we live in a survivable one. But let us pause on the imagery. Imagine standing before a boiling cauldron, each bubble rising and bursting, birthing entire universes. Some vanish instantly, some stabilize, some glow briefly, then fade. Others endure, expanding into realms of galaxies and stars. Now, zoom out. The cauldron itself never stops. It boils forever, bubbling with infinite creation. That cauldron is the inflationary field, and you are a spark inside one bubble, drifting in an eternal froth of universes without end. Eternal inflation shifts our perspective in terrifying ways. Our universe is not the whole. It is not even a fraction of the whole. It is a single bubble in an infinite storm, and that storm is indifferent to us. Inflation does not know life. It does not know consciousness. It simply expands, bubbling universes endlessly, like a blind fountain of possibility. And yet, within this blind process, meaning emerges. For if eternal inflation is true, then every possible kind of universe exists somewhere. Every law of physics, every combination of constants, every pattern of reality. And that means that life is not an anomaly, it is inevitable. If the dice are rolled infinitely, every outcome occurs, including us, including you. But there is another layer of awe here. If bubbles are forever separated, causally disconnected by inflating space, then we will never know them. We will never touch them, never measure their stars. They are not just far away, they are unreachable. For all practical purposes, they are invisible, and yet, their existence reshapes our philosophy. They demand we let go of the comforting notion that our universe is the universe. They force us to see reality not as a singular stage, but as a multiverse, a theater of countless performances, each playing under different rules. Of course, not all physicists agree. Some dismiss eternal inflation as a mathematical trick, a seductive idea without proof. Others embrace it as the logical consequence of equations too precise to ignore. But regardless of belief, the image it paints lingers, a universe of universes, bubbling endlessly in the dark. And perhaps this image is not entirely alien to us. Ancient myths, from Hindu cosmology to Norse sagas, spoke of cycles, layers, and infinite worlds. Eternal inflation, in its strange way, is a scientific echo of these ancient intuitions. We are living in one of countless realities. The others are forever out of reach, but their presence is written into the very mathematics of creation. So what does this mean for us? Here, in our fragile bubble, it means that our universe may not be a miracle. It may be a statistical fluke. It means that life is not a singular triumph, but one note in a cosmic symphony that plays across infinite universes. And yet, this does not diminish us. It elevates us. For in the blind boiling of eternal inflation, we are proof that the cosmos can give rise not only to stars and galaxies, but to beings who can ask why. Out of infinite possibility, here we are conscious, questioning, staring back at the cauldron that birthed us. The Level 1 multiverse gave us infinite reflections, other versions of ourselves, scattered across endless space. Level 2 gives us infinite diversity, other universes, each with its own laws, its own story of creation. Together, they reveal a reality far stranger than we once dared imagine. But the journey does not end here, for beyond the bubbling foam of inflation lies another mystery, one born not in the vastness of space, but in the smallest experiments of physics. A mystery that suggests every quantum event spawns new universes, branching endlessly. A mystery that hints at immortality, identity, and the infinite splitting of self. This is where we go next, into the quantum realm, into the Level 3 multiverse, where every possibility not only exists, but happens. The human imagination has always been haunted by cycles, the rising and setting of the Sunday, the phases of the moon, the turning of seasons, life and death and life again. It should come as no surprise, then, that some of the boldest visions of the multiverse are not of beginnings and endings, but of endless return. In ancient Hindu cosmology, the universe itself was cyclical. 4 ages, yugas, rolled endlessly forward, each beginning in harmony and collapsing into chaos before being reborn anew. In Greek myth, the phoenix burned in fire only to rise from its ashes. We have always sensed that reality might not march forward in a straight line, but spiral, looping back into itself. And as modern cosmology wrestled with the multiverse, this ancient intuition found new form. The first scientific cycles came from the equations of Einstein himself. His general theory of relativity allowed for a cosmos that could oscillate, expanding, collapsing, expanding again. The cyclic universe became a serious idea in the early 20th century. It was comforting, almost poetic. The universe had no beginning, no end, only an eternal heartbeat. But there was a problem: entropy. Entropy is the slow drift of energy from order into disorder. Fires burn into ash. Stars collapse into cinders. Every process adds to the tally of chaos, and entropy does not reset with each cycle it accumulates. If the universe had collapsed and been reborn infinitely, our cosmos should be buried under mountains of disorder. Instead, we see stars, galaxies, an intricate structure. Order exists, life exists, and so the simple cyclic model was abandoned. Yet, like the phoenix, the idea refused to die. Enter Roger Penrose, one of the great minds of modern physics. Penrose proposed conformal cyclic cosmology. His vision, in the unimaginably distant future, when all matter has decayed, when black holes have evaporated, when the universe is nothing but a featureless soup of radiation, entropy would cease to matter. Scale itself would vanish, and in that scaleless emptiness, the universe could be reborn, indistinguishable from the hot, dense state of the Big Bang. In Penrose's eyes, the past and the future are mirrors. One cosmic aeon flows into the next, a chain of universes without beginning or end. Our Big Bang was not the first. It was the afterglow of a previous universe's death, and someday, the light of our own fading cosmos will seed the birth of another. It is a vision that replaces despair with continuity. Even as everything dies, something lives again. But Penrose is not alone in imagining cosmic rebirth. In the 1980 seconds, physicist Lee Smolin proposed a daring idea: universes born from black holes. We tend to think of black holes as endings, cosmic traps from which nothing escapes. But Smolin turned the idea inside out. What if, inside a black hole, a tear in space-time gives birth to an entirely new cosmos? A universe pinched off from ours, with its own dimensions, its own stars, its own laws. Smolin called this idea cosmic natural selection. Each black hole becomes a seed. Each seed becomes a universe. And just as organisms evolve by passing traits through generations, so too might universes. The laws of physics themselves could mutate with each birth. Universes that make more black holes produce more offspring, and over time, these universes come to dominate the multiverse family tree. In this picture, our universe is not unique. It is a child among countless siblings, the product of a cosmic evolutionary process. And the fact that we live in a universe rich with stars, and thus black holes, is no accident. It is the evolutionary signature of a cosmos, fine-tuned to reproduce. It is an unsettling idea that our universe might be the descendant of some ancient black hole in another universe, and that the black holes in our skies are birthing baby universes right now. Not all cyclic visions are so evolutionary. Some are fiery, violent, almost mythic. Paul Steinhardt and Neil Turok, drawing from string theory, proposed the ekpyrotic universe. In their model, our universe is not alone, but a three-dimensional sheet, what physicists call a brain, floating in higher dimensional space. From time to time, these brains collide, and when they do, the energy released creates a Big Bang. The cosmos, then, is reborn not from collapse, but from collision. Each cycle begins in fire, expands, cools, then drifts toward the next collision. Like phoenixes in higher dimensions, universes die and are reborn forever. This model solves the problem of entropy by scattering it across dimensions, resetting the stage each time. And though it remains controversial, it offers a poetic vision. Our universe exists because two invisible sheets of reality brushed against each other in the dark, igniting creation. These theories differ: Penrose's graceful conformal cycles, Smolin's evolutionary black holes, Steinhardt and Turok's fiery brain collisions, but they share a common heartbeat. They refuse to accept that the Big Bang was the absolute beginning. They see our universe as one moment in a larger story, one verse in a cosmic poem. And whether or not these ideas are correct, they open our minds to a deeper truth. Beginnings may be illusions. What we call the origin may only be transition. What we call creation may only be transformation. Stand beneath the stars and imagine them not as eternal, but as part of a cycle far greater than themselves. Every supernova could be a birth cry, every black hole a womb, every cosmic death the seed of another reality. The multiverse at level 2 is not only about diversity, different laws, different constants, different universes bubbling from inflation. It is also about history, about cycles, about the possibility that universes evolve, die, and are reborn in endless succession. And here, philosophy meets physics, because if reality is cyclical, if death is always followed by rebirth, then perhaps the multiverse is not only a description of the cosmos, but a metaphor for life itself. We die, but others are born. Stars collapse, but galaxies rise. Universes end, but the multiverse continues. In this vision, meaning is not found in permanence, but in renewal. Yet we must remember, these are theories, not certainties. The equations are seductive, but the evidence is thin. For now, we have no way to peer inside black holes, no way to touch the higher dimensions of brain cosmology, no way to see beyond the horizon of our own cycle. These visions may be correct, or they may be poetry disguised as physics. But that too is part of their power. They remind us that science is not just about answers. It is about questions bold enough to reshape our sense of existence. The Level 2 multiverse shatters the notion of a single beginning. It opens the door to eternal processes, universes, bubbling, cycling, evolving, colliding. It suggests that what we call reality is not the whole story, but one page in an infinite book. And as strange as this is, the journey is only deepening. For beyond the cosmic cycles lies a multiverse stranger, still one born not of galaxies or black holes, but of quantum paradoxes. A multiverse where every particle, every decision, every possibility branches into new realities. This is the Level 3 multiverse. And if Level 2 humbled us with diversity, Level 3 will shake us with immortality. If Level 1 multiverse theories are born from the immensity of space, and Level 2 from the violence of cosmic inflation, then Level 3 emerges from something far smaller, yet infinitely more mysterious: the quantum. The smallest experiments in physics suggest that reality itself may be splitting all the time, spawning parallel universes with every flicker of possibility. To begin, we must return to one of the strangest experiments ever conceived, the double-slit experiment. In the early 1800s, Thomas Young asked a simple question: is light a wave or a particle? He built an apparatus that still feels like a magic trick. A beam of light was directed toward a screen. In between, Young placed a barrier with two narrow slits. If light were particles, the screen should show two bright stripes as the particles passed through one slit or the other. If light were waves, each slit would act as a source, the waves spreading out and interfering, creating a pattern of bright and dark bands. When Young performed the experiment, the result was astonishing. The screen glowed not with two stripes, but with an interference pattern, light behaving like a wave. Light, it seemed, could ripple. For a century, this wave picture held, but in the early 20th century, quantum mechanics arrived like an earthquake. Light was also particles, photons, and the double-slit experiment became a riddle. Send photons through one by one, and you still get an interference pattern. Each photon behaves like a wave, passing through both slits simultaneously. Yet when it strikes the screen, it registers as a particle in a single spot. Wave and particle, both true, a contradiction at the heart of reality. Physicists scrambled for explanations. Niels Bohr and Werner Heisenberg proposed what became known as the Copenhagen interpretation. The wave is not a wave of stuff, but a wave of probability, a mathematical haze describing where the particle might be found. The act of measurement collapses this haze into certainty. The photon appears here, not there. Reality, they said, is defined by observation. But this solution raised more problems than it solved. What counts as a measurement? Does consciousness collapse the wave function? If no one is looking, does the photon even exist? These questions cut so deeply into philosophy that many physicists simply shrugged and moved on, preferring to shut up and calculate. Yet one young physicist refused to shrug. Hugh Everett, in 1957, offered a radical idea. What if the wave function never collapses? What if every possibility encoded in the wave actually happens but in separate universes? This is the many worlds interpretation. According to Everett, when a photon passes through the double slits, it does not choose one path. It takes both, splitting reality into branches. In one universe, the photon goes through the left slit, in another, the right, in another, both. The interference pattern exists because these universes are layered atop each other, their wave functions still coherent. When decoherence occurs, when the universes lose contact, we see only one outcome. But the branching does not stop with photons. Every quantum event causes a split. Every particle, every atom, every neuron in your brain. And because you are made of particles, you split too. In one universe, you observe the photon in position A. In another, you observe it in position B. In each universe, you are convinced that you are the original. Reality is no longer singular. It is a tree, branching endlessly, universes multiplying with every heartbeat of time. The implications are staggering. If Everett is right, then every possibility is real. Every coin toss, every roll of the dice, every choice you make. Somewhere, you took the other path. Somewhere, you said yes instead of no, stayed instead of leaving, lived instead of dying. This is the level 3 multiverse. Unlike level Y and 2, which are spatial other universes far away or sealed in bubbles, level 3 is personal. It unfolds right here, right now, at the quantum level of existence. You are not just one person. You are an infinite constellation of selves, diverging with every decision. Some physicists recoil at this vision. Nobel laureate Gerard Hooft once dismissed it as wasteful, creating stupendous numbers of parallel worlds just to explain a few quantum probabilities. Others argue it is the only way to take the equations seriously, the only interpretation that avoids adding unproven collapse mechanisms. As Sean Carroll once said, the many worlds interpretation takes quantum mechanics literally. Every other interpretation is trying to wriggle out of it. Still, Everett's idea was so radical, it was largely ignored in his lifetime. He left academia, disillusioned, and died young. But in the decades since, many worlds has risen from the margins to the mainstream. To some, it is not only plausible, but inevitable. And here is where philosophy intrudes. If you split every time a possibility occurs, what happens to your identity? Is the you listening to these words the only you? Or are there countless others, diverging with every word, every second? Imagine tossing a coin where heads means survival and tails means death. In the Copenhagen view, you have a 50% chance of dying. In many worlds, both outcomes occur. There is a universe where you die, and there is a universe where you live. From your perspective, you always find yourself on the path where you survive. Immortality, of a strange and unsettling kind, emerges from the math. You may die in most universes, but in at least one, you go on. And subjectively, that is the one you will always experience. This is not comfort. It is horror and wonder entwined. For immortality in the many worlds sense is not eternal joy, but eternal branching, forever living, forever splitting, forever multiplying. Think about this. The next time you flip a coin, countless universes will be born. The next time you speak a word, countless selves will diverge. The next time you breathe, reality itself will split. We live not in a single universe, but in an ocean of possibility, branching infinitely. And here we find ourselves at a crossroads. Level I gave us infinite reflections. Level 2 gave us infinite diversity. Level 3 gives us infinite selves. Each level is stranger than the last. Each forces us to surrender more of our cherished illusions of uniqueness, of singularity, of continuity. The quantum multiverse is not a place out there. It is happening here, beneath your skin, inside your atoms, in every photon that strikes your eye. The multiverse is not distant, it is intimate. And yet, this intimacy is also its terror, for it raises the question no equation can answer. Which of these yous is truly you? Perhaps all of them, perhaps none. Perhaps you is not a fixed entity, but a wave function spread across universes, decohering into branches with every moment. Perhaps your identity is not singular, but plural, as infinite as the cosmos itself. This is the level 3 multiverse, not galaxies beyond our reach, but lives beyond our comprehension, not distant universes, but parallel selves. And just when we think the paradox cannot grow deeper, we arrive at level 4, the strangest of all, a multiverse not of space, not of bubbles, not of quantum splits, but of mathematics itself. A multiverse where every logical possibility is real, where we are not flesh and blood but equations, where existence itself is number. What does it mean to live forever? For centuries, immortality was a dream reserved for myths and religions, the elixirs of alchemists, the heavens of prophets, the digital fantasies of futurists. But in the strange corridors of quantum mechanics, immortality sneaks in not as promise, but as paradox. It arrives disguised as mathematics, whispering through the equations of the many worlds interpretation. If every quantum event spawns universes, then death is never absolute. Somewhere, the coin lands on heads. Somewhere, the bullet jams. Somewhere, the heart keeps beating. You may die in countless universes, but in at least one, you live. And from the inside, it will always feel like survival. Let us picture this paradox. Imagine a coin tossed into the air, a coin with your life at stake. Heads, you live. Tails, you die. In a classical world, the odds are simple, 50/50. But in the level 3 multiverse, both outcomes occur. The universe splits, one where your story ends, and one where it continues. Now imagine tossing the coin again, and again, and again. In one universe, you die quickly. In another, you die slowly. But in at least one branching path, the coin always falls in your favor. A string of impossible luck. Heads, heads, heads forever. And you, the conscious, you will always experience that path. This is called quantum immortality, a disturbing consequence of many worlds thinking. At first, it seems exhilarating. Death cannot catch you. No matter the danger, some branch of reality carries you forward. In some universe, the car swerves, the cancer retreats, the accident never happens. You survive, always. But think deeper. What does survival mean when it comes at the cost of infinite other yous, suffering infinite other deaths? What does it mean when immortality is not a gift, but a narrowing corridor of improbability, where you keep walking because every other version of you has already fallen away? In this vision, immortality is not eternal youth, not paradise, not triumph. It is a lonely march through the collapsing branches of reality. You live on, yes, but in increasingly improbable worlds. The universe conspires to keep you alive, but only by strangling possibility around you. Philosophers recoil at this. Is identity really continuous across universes? Is the you in the surviving branch the same as the you that fell in another? Or are these separate people, each with their own legitimate existence? Some argue that quantum immortality is an illusion, that continuity of consciousness cannot be guaranteed across splits. Others insist it is inevitable, baked into the logic of branching universes. Either way, the paradox forces us to confront unsettling questions. If you can never subjectively experience your own death, is death real at all? If consciousness always persists somewhere, does that persistence count as survival? And if it does, what kind of survival is it? A blessing? A curse? The strangeness grows when we connect this paradox to the wider multiverse. Remember level I, infinite universes stretched across infinite space. Remember level 2, bubble universes with different laws of physics. The many worlds branching of level 3 is not separate from these. It overlays them, multiplies them. Each branching path spawns its own bubble universes. Each bubble contains its own infinities. Reality becomes a Russian doll of eternities, each filled with countless versions of you. And somewhere, in some slice of infinity, you live forever. Not because biology grants it, not because divinity blesses it, but because mathematics demands it. But immortality at this scale is not comfort. Imagine living long enough to see stars die, galaxies fade, space stretch into emptiness. Imagine a life where death never comes, but everything else does. Friends vanish, civilizations crumble, even the universe itself dims into blackness. To live forever in the quantum sense may not be to triumph, but to endure, to outlast everything, until endurance itself becomes meaningless. This is the shadow side of immortality. It asks, would you really want to live forever, if forever meant watching all else fade? And yet hidden in the horror is something profound. If death is never absolute, if consciousness persists in some form, then perhaps the real lesson is not fear, but responsibility. Every choice you make branches reality. Every act creates universes. Somewhere, you succeeded. Somewhere, you failed. Somewhere, you broke a heart. Somewhere, you saved one. The multiverse is not just physics, it is ethics. To live in a many worlds reality is to live knowing your choices echo endlessly. Immortality, then, is not just survival, but the infinite weight of consequence. So where does that leave us? Are we immortal quantum beings, walking endlessly through branching corridors of survival? Or are we finite creatures, tethered to a single fragile thread, with death the true end? The truth may be both. From the outside, you are mortal. Bodies break, stars explode, universes collapse. From the inside, you are immortal. Consciousness never experiences its own absence. Death is always elsewhere, always in another branch. The story of you always continues, because you are always inside it. Perhaps this is the final paradox of the Level 3 multiverse. Death is both real and unreal, final and never final. The coin lands on tails in countless worlds, but never in yours. You walk forward, step by improbable step, into eternity. We began the quantum journey with a beam of light through 2 slits. We arrive here with immortality whispered in the mathematics of waves and probabilities. Physics, it seems, is not only a science of particles and forces, it is a mirror held up to existence itself. And in that mirror, we glimpse both wonder and dread. But the journey does not end here. Beyond the branching universes of Level 3 lies the most radical vision yet, a multiverse not made of matter or energy, but of mathematics itself, a reality where equations are existence and every logical possibility is real. Welcome to the Level 4 multiverse. We've traveled through infinities of space, through bubbles of eternal inflation, through the endless branching of quantum possibility. Each level of the multiverse has stripped away more of our illusions, forcing us to let go of the comforting notion that our universe is the only stage. But now we arrive at the most radical vision of all, a place where physics dissolves into mathematics, and mathematics becomes reality. This is the Level 4 multiverse. Look around you. The chair beneath you, the air around you, the screen in front of you, it feels solid, real. But science tells us it is not. Matter is atoms. Atoms are particles. Particles are excitations of invisible fields. At every layer, reality gets thinner, less material, more abstract. And at the very bottom, we find not stuff at all, but equations. Max Tegmark, a physicist at MIT, took this realization to its boldest conclusion. He asked, what if reality itself is mathematics? Not just described by mathematics, not just modeled by equations, but made of mathematics. In Tegmark's vision, every consistent mathematical structure exists, not in some platonic heaven, not just as symbols on paper, but as actual universes. Our universe is simply one of them. Its laws of physics, its constants, its particles, all of these are features of a particular mathematical structure. Somewhere in the Level 4 multiverse, other structures exist with entirely different laws. In one, gravity may be repulsive. In another, time may loop back on itself. In still another, space may not exist at all. If it can be written down mathematically, Tegmark argues, it exists. This is not a multiverse of space, like Level 1, not a multiverse of bubbles, like Level 2, not a multiverse of branching realities, like Level 3. This is the multiverse of pure possibility, the set of all consistent mathematical realities. It is not embedded in anything. It is the foundation beneath everything. Think of it like this. Imagine a library, but not a library of books, a library of equations. Each equation is a universe, each page a law of nature, each symbol a particle, a force, a dimension. The Level 4 multiverse is the infinite library of existence, and we are one story among its endless shelves. The consequences are staggering. The fine-tuning problem that haunted physicists vanishes. Of course, our universe appears tuned for life, because in the Level 4 multiverse, every universe exists. Most are barren, most are sterile, but some, by pure chance, allow complexity, consciousness, meaning, and naturally, we find ourselves in one of those. In this view, our universe is not chosen, it is not designed, it is sampled, one possibility among uncountable others, a statistical inevitability. But there is another consequence, even stranger. If reality is mathematics, then we are mathematics. Consciousness itself is an emergent pattern in the equations. The feeling of being alive, of existing, is what it feels like for mathematics to contemplate itself. We are not outside the equations looking in. We are inside them, living them. This thought collapses the boundary between science and philosophy, between physics and metaphysics. If we are mathematical beings, then existence itself is a kind of simulation, though not necessarily running on a computer, not powered by silicon chips or alien machines. The hardware is irrelevant. The structure is enough. Just as a triangle exists independent of whether anyone draws it, so too do universes exist independent of whether anyone observes them. In the level 4 multiverse, to exist is simply to be mathematically consistent. This idea unnerves many physicists. For some, it is too abstract, too untestable, too close to metaphysics. How do you measure another mathematical structure? How do you detect universes that exist only as equation? Critics argue that this is philosophy masquerading as physics. And yet, there is a strange inevitability to it. If mathematics describes everything we observe, if the equations of physics explain every measurement we make, then where does mathematics stop and reality begin? The line blurs until it disappears. Reality is math. Math is reality. But let us step back and imagine. Picture a landscape not of mountains and rivers, but of equations and symmetries. Picture universes blooming like fractals, each obeying its own mathematical code. In one, electrons orbit nuclei. In another, particles are knots of higher dimensional space. In another, consciousness arises without matter, purely as logic unfolding. Now ask, what does it mean to be alive in such a landscape? What does it mean to search for purpose, if we are no more than patterns of numbers? Perhaps meaning itself is the answer. Out of uncountable mathematical structures, we inhabit one where equations gave rise to beings capable of asking questions. We are the proof that mathematics can become self-aware. We are equations that wonder why equations exist. This is the ultimate inversion. We began our journey with stars and galaxies, with telescopes peering into the sky. We end it by staring at symbols on a page, and in those symbols we see infinity. The level 4 multiverse is the end of the road and the beginning of every road. It is the place where science collides with philosophy, where physics dissolves into logic, where existence itself becomes indistinguishable from mathematics. But there is one more twist. If all mathematical structures exist, then all possible universes exist, not just those with different physics, but those with different histories. Somewhere, there is a universe where Rome never fell. Somewhere, there is a universe where you were never born. Somewhere, there is a universe where the constants are different, the laws are strange, the very fabric of reality is unrecognizable. And yet, each is as real as ours. Each is a page in the infinite book. The level 4 multiverse asks us to surrender our last illusion, that of uniqueness. It tells us we are not the pinnacle of creation, not the center of existence, not even a particularly special arrangement of physics. We are a solution to an equation, a pattern among patterns. And yet, does that make us smaller or greater? If we are mathematics, then we are eternal. Equations do not decay, numbers do not die. To be real in the level 4 multiverse is to be forever written into the structure of existence. We may fade as matter, but we endure as math. This is the last frontier of the multiverse. Level I gave us infinite copies. Level 2 gave us infinite laws. Level 3 gave us infinite selves. Level 4 gives us infinite everything. Here, the fog of unknowing does not lift. It becomes absolute, for beyond mathematics there is nothing left to say. And yet, perhaps that is the point. The multiverse was never about answers. It was always about questions. Questions that open our minds, expand our vision, stretch our imagination to the edge of reality itself. And so we arrive here, at the threshold of speculation and wonder. The multiverse may be real, or it may be illusion. It may be science, or it may be philosophy. But one thing is certain. In searching for it, we discover not only the universe, but ourselves. We have walked through infinities. We have stood at the edge of space and seen endless galaxies beyond our reach. We have wandered through bubble universes foaming in eternal inflation. We have split into countless selves in the quantum labyrinth. We have dissolved into mathematics at the final frontier. And yet, after all this, one truth remains. The multiverse is not an answer. It is a question wrapped in fog. When Edward Quinn painted his atlas of the world in the 19th century, he imagined clouds retreating with every page, new lands revealed beneath them. At last, the clouds were gone, the earth complete. Today, we know the cosmos is not like that. Every time a cloud lifts, another appears. Every mystery solved opens onto deeper mysteries. The multiverse is the largest cloud yet. It is the suspicion that even our greatest discoveries, Big Bang, relativity, quantum mechanics, are only glimpses through mist. That behind the universe we know, there may be uncountable others, and behind those, still more. Some scientists see inevitability here. They argue that inflation practically demands eternal inflation. That string theory, however incomplete, almost insists on a landscape of universes. That quantum mechanics, taken seriously, implies branching realities. To them, the multiverse is not speculation, it is consequence. Others recoil. They argue that if universes can never be observed, never be measured, then the idea is not science at all. That to speak of realities forever beyond our reach is no different than myth. To them, the multiverse is a distraction, a seduction of mathematics untethered from experiment. Both sides claim rigor. Neither holds the final word. The fog remains. But perhaps the fog is not a barrier. Perhaps it is the point. Think of a child staring at the night sky for the first time. They do not know the names of the stars, or the mechanics of fusion, or the equations of gravity. What they know is wonder, mystery, the dizzying sense that reality is larger than themselves. That feeling is the beginning of science, of philosophy, of art. It is the beginning of everything. The multiverse returns us to that place. It reminds us that despite all we know, we are still children staring at the sky, that humility is not weakness, but truth. And maybe, just maybe, the multiverse is less about physics than it is about perspective. If there are infinite universes, then our universe is not the universe. It is one verse in an eternal poem. Our lives, our struggles, our civilizations are not the pinnacle of creation, but single notes in a cosmic symphony. At first, that thought is crushing. We are small, insignificant, but look closer. Out of infinite possibility, here we are, out of countless barren universes. This one gave birth to stars, planets, and life. Out of endless configurations of matter, one arrangement can wonder why it exists. Out of mathematics itself, consciousness arose. We are not insignificant, we are improbable, and improbability is precious. What then should we do with this knowledge? If universes are infinite, if selves are infinite, if realities are infinite, does anything matter? The answer is yes. Precisely because of the vastness, this moment matters. This life, this earth, this fragile patch of reality is the only one you will ever experience. Out there, in some other universe, another, you may be listening to different words. But here, now, these words are yours. This life is yours. Meaning is not erased by infinity. Meaning is created by attention. The multiverse humbles us, but it also elevates us. It says, you are not the center of existence, but you are part of it. You are woven into the fabric of reality, at every scale, from the atoms in your body to the galaxies overhead. And even if countless universes exist beyond, that does not diminish the wonder of this one. Perhaps the true lesson of the multiverse is not escape, but presence. Not to dream of other realities, but to cherish this one. Not to vanish into speculation, but to live with eyes open to the mystery. We began with clouds of ignorance. We end with clouds of possibility. The fog has not lifted. It never will. But maybe that is what makes the journey worthwhile. For in the fog, there is always more to discover, more to imagine, more to become. The multiverse may be unreachable, It may forever remain beyond our telescopes, beyond our equations, beyond the grasp of science. But even if we never prove it, the idea itself has already expanded us. It has stretched our vision, widened our imagination, and reminded us that reality is not a closed book. It is an unfinished epic. So we leave the multiverse, not with certainty, but with wonder, not with final answers, but with deeper questions. What is real? What is possible? What is consciousness? Why is there something rather than nothing? These are not questions with endings. They are questions that keep us alive, keep us searching, keep us human. And as we gaze into the fog that remains, one truth shines through. The universe is not small. Existence is not simple. Reality is not finished. We are still at the beginning,